All right. Hello, folks. I think I'm live. I am. All right. So thank you for joining today. Let me switch over to a different screen here. We're going to be talking about our data stack architecture on EMR and CDK. So I'm just going to spend a few minutes just kind of prepping. I'm still a YouTube streaming noob, so I'm still figuring a lot of this stuff out. Let's see. My tweet that went out didn't even have the correct stream. So let me go ahead and fix that and tweet it out, and then we'll get started in just a little bit here. Let's copy that link. Cool. All right, so there's the link. Let me go ahead and update Twitter. All right, let's see here. See, this is, friends, this is why you do a live stream with somebody that's there to help you tweet and answer questions. So, hi, I'm Damon here. Today's live stream is brought to you by, let's see, Seattle Rain, my startup coffee mug, and my mom. Hi, Mom. Hope you're watching the stream. Anyway, so let's get started today. So what we're going to do is I'm going to go through building a big data stack using AWS CDK. So if you're not familiar with CDK, it's kind of like Terraform. It's your infrastructure as code. We'll dive in and show some examples pretty soon. But what I've got on the screen here is this is the architecture that I'm going to build. So using CDK, I'm going to build this all the way from the ground up. So I'll build my VPC. I will build a Hive Metastore, an RDS MySQL instance. I will build EMR and EC2. And then we'll move over to actually going EMR on EKS. So I'll build an EKS cluster. I'll get some things installed on that EKS cluster, like the cluster autoscaler, even Apache Airflow, and then we'll also build an EMR virtual cluster that connects to that EKS cluster. So it's going to be a lot of fun. The other thing that I want to do, I want to show my data container stack. So I do a lot of work in kind of building my own data lake. I always like to have some example data that I can use. And I have another CDK stack that I use to build that. So I want to show that as well. So let me take a sip of my coffee and we will get started here. All right, cool. So let me open up VS Code. So inside of VS Code, I want to show first my data containers stack. So let me pull this up. So with CDK, it's pretty straightforward to go ahead and build your infrastructure using different code. So CDK, actually, let me open up the CDK page. So Cloud Development Kit will support a bunch of different languages. There's TypeScript, Python, and Java. Those are the defaults, and so you can build your infrastructure using any of those different languages, which is pretty cool. And then if we go to the CDK repository as well, let's see. I believe the Go version of CDK just came out as well. So now there's a Go one that's in testing. I just saw somebody tweeting about it the other day. But so yeah, if you want to use Go, you can do that now. I think that's in testing, and yeah, that was so yeah, CDK is pretty cool. I haven't really used it before, and I just wanted to see what it would take to actually get a data stack up and running. So the first thing I'm going to do is I'm going to deploy some Docker containers to ECS, actually. And so I mentioned I've been kind of messing around with kind of this data extraction framework that just uses Docker. And so oftentimes when I'm going and finding a new API or extracting data, I find it really tough to get started. Like I need to download, find the right library. Is it in Python? Is it in Ruby? I need to download that stuff. I need to install all the different requirements. Sometimes I just want to run a Docker container and get data from an API. So I've been kind of messing around with this thing I've called cargo crates. And I built a few different containers in cargo crates to access data from YouTube or Twitter or GitHub, all this kind of stuff. What this is actually, the intent behind this is I have my own data lake that I build. And what it does is it takes a bunch of data from GitHub and my laptop and my health ring, and then dumps it into S3. And it does that using a combination. The previous version did that using a combination of Glue Python shell and Kinesis data streams. But this one, I wanted to see if I could spin it up on containers. So I've got my cargo crates thing here. And let me just do a quick example of what it looks like to go and run one of those. I've got a few different ones in here. And let's see. The one that I want to use is this fatherhood one. So let's go ahead and pull up a terminal. Okay. And let's do a docker run. And I think I can just do ghcr.io dacort crates fatherhood. So this is a crate, this is a Docker container that goes out to an API, pulls back some data. Let's see what that looks like if I just go ahead and run it. It's going to go ahead and pull that Docker container. And then that Docker container goes make some API requests, and now I have some dad jokes. So let's start by saying, why do bees hum? Because they don't know the words, right? So I have a bunch of different containers that I can use to extract data. There's another one that I have for GitHub. And so let's say docker run-e GitHub. Well, we'll play with that later. That doesn't really matter right now. But so what I've done is I've gone ahead and I've created this data container stack on CDK. This stack is pretty straightforward. It just creates a CDK app and pulls in a data container stack and adds a glue crawler as well. So if I look at this code, what I've got is I've got my data container stack here, and this creates everything from the base, right? So it creates a VPC, and then it goes ahead and creates an ECS cluster that it just calls cargo crates. It goes and gets a bucket. So if I want, one cool thing about CDK is you can provide contexts if you want. So you can provide a parameter that comes in and say, okay, I want to use this bucket for my data. Or it can also go ahead and just create a bucket automatically. So usually it's recommended to go ahead and create that bucket because that'll create a dynamic name. And once you use a name, especially with S3, that's a global namespace, and so it's taken forever. So it's usually recommended to just kind of create that name dynamically, because ideally you shouldn't have to worry about the name of the bucket. The other thing that we do is we create a couple different data containers in ECS. So I have a container that's pulling my GitHub traffic and another container that's pulling my views for YouTube. The other cool thing about CDK is if you need to grant access to different resources, it's really, really easy. So I've got my data bucket here that returned an S3 bucket, and then I can just say data bucket grant read write to that ECS task. So that's pretty cool too, because I can just say, okay, go ahead and create this bucket, create this ECS task, and then just make sure that that task can actually read and write to the bucket. And I can do that with my YouTube one as well. So it's pretty awesome to be able to kind of construct those resources like that. So what do these tasks actually look like? Well, let me pull open the GitHub traffic one as an example. So I've got a bunch of different repositories that I maintain, and I want to see, on a daily basis, kind of what the traffic is to those repositories, so I can know, which ones are more popular and which ones I should focus on. So I've got a set of repos here, and then I just create a scheduled task with CDK that returns this scheduled Fargate task. So I'm actually going to run this on Fargate. So the other nice thing about CDK is it's got a bunch of different patterns kind of built into it. So if I wanted to actually pull up the documentation for this, let's say, um, there's my scheduled Fargate task. Let's zoom in a little bit for y'all. And so what we have here, this is the documentation for the most recent version of CDK. And you can see you can easily create a new scheduled Fargate task. And these are all the properties that you can pass into it. So you can pass in a schedule, an ECS cluster, if it's enabled or not, the Fargate platform. So all these different things you might need to configure that scheduled task. So if I'm back over here, I create my scheduled Fargate task, I give it an ID, I pass it the cluster that I just created, I pass it a schedule, so I'm going to say, okay, go ahead and schedule this every hour. So just while I'm testing this, I wanted it to run every hour. And then I can pass in the Fargate task image options. So I'm pulling an image from the GitHub container repository, I'm passing it my command, and then I can set an environment variable as well. So I've got kind of a utility that runs on that crate that dumps the data out to S3. And so again, this is where I can parameterize things a little bit. So I passed in the S3 bucket that I created, and I can just say, get my S3 URL for that bucket. And I pass that in, and it just gives me the S3, ://. So that is all dynamic there. I'm also using GitHub Secrets Manager, or not GitHub Secrets Manager, sorry, AWS Secrets Manager, to store some secret data. And so the way that that looks, I can easily create a secret in there that says, here's my YouTube API key, or here's my GitHub personal access token. And then in my stack, I can just kind of pull in that environment variable. And that's just a feature of ECS. And then I'm doing the same thing for YouTube videos as well. I've got a set of video IDs that I want to gather statistics on. I create a scheduled Fargate task, and this time pulling from my YouTube container, and again, dumping out to S3 and using the secrets manager. So if I go ahead and deploy this, what does it actually look like? Well, let me switch over to my ECS console. So I've got a couple clusters here. This one down here was manually created. This is the data container stack that CDK created. So you can see it's got a bit of a dynamic and unique name in there. So in that data container stack, there's not much in here because it's just scheduled tasks that are running on a regular basis. So if I click on my tasks and then stopped, you'll see the last couple runs of my tasks down here. So I've got a GitHub traffic one and a YouTube video one. And so these are just running every hour. And if I click through to those task definitions, let's look at the GitHub one again. And so this is all configured from CDK. So CDK is creating all these, configuring all these, adding a role to them dynamically, and then in the code we saw the traffic, the command that we were being sent. So that all got populated into there. There's the environment variables, and again the secret, the GitHub personal access token secret, that's getting sent through. I don't know why my screen is flickering. So that's getting sent through as well. So that all got created from CDK. And when this runs, it's just going to pull data from GitHub and dump it out to S3. So in this case, it's going to dump it out to my dacort demo code location. So let me do a quick S3 ls of that. So, oops, 1 second. I just need to authenticate really quickly here. I'm going to put up my my screen. All right, cool. All right, we're back. So yeah, there's my demo code bucket. There's my where all my data is getting dumped out to. If I do a recursive listing of, let's say, GitHub, I'll do a recursive listing of that. And you can see here's all the data that's been dumping for the past week or two, and even some data for today. So if I look at that repository right there, let's just copy that down. Why not? Dacort demo code. We'll see what that looks like. And so this is just data that's being dumped from GitHub into S3. So I've got some basic stats in there. It's just JSON data and what popular paths are. So that's cool. I've got the data in there. Now I need to actually populate a data catalog somewhere with that. So let me go back to my CDK code, and I've got a glue stack in my CDK code as well. So I go ahead and I create a database for Damon's Data Lake. Then I also pull out a new bucket that is for my the data bucket that I'm using for this stuff. And then I create a crawler. And the nice thing here again is I just use the IAM role CDK construct to create this glue crawler role, associate it with glue, and say, use the AWS glue managed service role. So that pulls that in, creates myself a new role, and then I grant that role just read access to the S3 bucket. So this S3 bucket, I can grant read, I can grant write, I could do read write. Again, that's the nice thing about CDK. It's pretty flexible like that. And then I just create this crawler down here. So I say, all right, create a new crawler for my data lake, use this role, and put it in this database. And here's the paths that we want to crawl. I should have replaced the hard-coded S3 bucket in here. I just didn't get to that. I was kind of testing the crawler configuration, but that's all it takes to create a crawler in CDK. So if I go back over to here, and let's go over to my glue console. So here's the crawler that gets created from CDK, and there's the two different paths that we mentioned. And so when I ran that, it went ahead, crawled that bucket and created these tables in here. So now I've got a YouTube and a GitHub table that are sitting in there, and I can go and look at that, the details there. So that is so that's kind of my own personal data lake stack. So what I want to do, that is just kind of building the data ingest pipeline. What I want to do next is I want to show how to create um, a big data stack on top of this that I can use to kind of query this stuff. So that's going to be EMR, that's going to be a Hive Metastore, that's going to be EKS. So there's going to be all sorts of stuff. So let me take a quick drink of my coffee and I'll hop over to that next. Hope everybody's doing well today. It's a little rainy here in Seattle. But it's not too bad. We had a couple days of sun, so that should hold us over for another 2 months or so. All right, let's flip over to my other data stack. So again, with CDK, you can use, there's a CDK init command that kind of creates a default stack for you, which is really nice because you can take that and just kind of build out. So I've used that and then I've kind of customized it a little bit in Python. So I pull in a bunch of different stacks for my big data stack. And let me just pull up what the architecture looks like again, just to remind you of all the stuff that we're going to build. So I'm going to go ahead, create a VPC, create a Hive Metastore, create an EMR and EC2 cluster that's connected to that Hive Metastore. Then I'm going to create a Kubernetes cluster on EKS, install a couple things on there, and then also create an EMR Virtual Cluster that connects to that EKS cluster. So pretty busy, but let's see what that actually looks like. So in my CDK stack, again, first thing I'm doing is creating a VPC stack. So this just creates my own VPC in here. I've kind of broken this up into different modules just to make things a little bit easier, but this VPC stack is super straightforward, right? It just says, go ahead, create a VPC with 3 availability zones. I could use a VPC that already exists, or what is also common is kind of having a shared base stack that you then import into other stacks, but I'm just creating this entire thing from scratch. So there's my VPC, goes ahead and creates that, and that's going to get shared between these other stacks down the line. So the next thing I do is I create an Rds stack, and you can see I pass in my VPC there. So let's look at that Rds stack. So in here, I'm just creating a single MySQL instance. And let's see, how many lines of code is that? About 10 lines of code to go ahead and create my database instance. So I'm just saying use RDS MySQL and whatever the latest version of 8.0 is. Here's the VPC I want to use for it and the database name. And when I destroy the stack, go ahead and destroy that database as well. This is just a demo account, so totally fine with things getting deleted. And then I'm allowing MySQL from anywhere. I believe this is running in a private subnet, so that's not too big of a deal. But in other cases, you might want to allow from a specific security group or CIDR block or what have you. So, but right now, I just kind of have this allow from any in there. So that creates an RDS database. So let's just go and take a look at what that looks like really quickly. Rds Console. All right, so in my Rds console, here's the database that was dynamically created. And you can see if I look at the monitoring, I've got a few connections to there right now. And if I look at the connectivity, you can also see, here's my EMR demos VPC stack that was created. And then here's all the different security rules that are coming in. And so again, here's that, allow from any inbound on 3306. And so if I go back to my big data stack, the other cool thing about this is by default, CDK is going to use Secrets Manager to create the username and password for this database. So I don't even have to worry about figuring out what my username and password is going to be. So I created my Metastore. Now I want to create an EMR stack to go and access that Metastore. So create the EMR stack, pass in the VPC, we're going to name it and pick the EMR release label. And then this is where we're passing in the RDS secret and connection data. And so again, that secret got created automatically in the RDS stack, and I'm just kind of passing it into the EMR stack. So let's look at the EMR stack next. So in here, we've got a few parameters that are passed in, and we pass in that secret, The connections is essentially the security groups to that RDS cluster, so I can grant access to it from the EMR stack. And so if I look down what's going here, I create a few different things in before I start that EMR stack. So EMR has a service role and a job role. The service role is used by EMR to create new instances or scale a cluster up and down, do all those kind of back-end tasks that the cluster might need to do. And then there's a job role that's associated with all the jobs that run on that cluster. So I go and I have a couple functions in this EMR stack that go ahead and create that stuff for me. So the job role is a service principal for EC2, and then it pulls in, I'm just giving it read-only access to S3. So that's my EMR job role, pretty straightforward. Then if I go back up here, I create a service role as well. And so this is tied specifically to EMR, and it's using the new service policy v2. Cool. So all that stuff gets created. We create an instance profile too, and we also create a log bucket to put our EMR logs in. Nice. And then finally, with those new EMR service roles, you need to add a pass role. And so that is taking that service role that I created, adding a new policy statement to it that can allow that role to be passed around. So then I just need to configure my database. So I go to the Rds secret and I pull in the host and port and database name. I just pick a random subnet that I want to drop the EMR cluster into. And then EMR has this CFN cluster method that I pass all my EMR creation stuff to. So I can tell it, what instance types I want to use, how many of them, the release label, the log URIs, and then the applications that I want to put on the cluster too. So in this case, I'm going to use Spark and Hive, and I'm also putting Livy and Jupyter Enterprise Gateway so I can use EMR notebooks on top of this cluster. Finally, in order to connect this cluster to the Hive metastore that I created, I need to pass some Hive site configuration properties. So I'm doing that here. And again, I'm building these strings all dynamically in this CDK code. So I pulled out the RDS hostname and port from the secret. I'm pulling in the username and password from that secret and then setting these as the configuration properties. The other thing with those new EMR managed policies is you need to tag the cluster with a specific tag. So I'm able to add tags here in CDK as well. And then that's pretty much it. So that is going to go and create the EMR cluster. One thing I did have, I do add access to RDS inside the EMR stack. And that's just because the EMR stack is going to know what its IP address is and all that kind of stuff. So I pass in the RDS connections parameter, and then I can say connection.securityGroups, add an ingress rule. So I am adding a specific ingress rule for my EMR cluster to be able to access that MySQL image. So if I go back to EMR, let's look at my clusters here. I've got a few failures while I was trying to figure this all out. But here's my EMR with Hive Metastore cluster there. And so if I go in there, this is all the stuff that we saw in the CDK stack. So that's the release label I'm using. These are all the applications. There's my log bucket that got created dynamically by CDK. And then, yeah, this is my EMR stack. And we can see in the configurations, there is my Hive site configuration that I kind of put together there. So what I'm going to do is, now that I've got this EMR cluster up and running, I've got a notebook that I created to go ahead and populate my Hive metastore. So let me start that notebook really quickly, and we'll pull that up and see how that goes. But that is, so yeah, that's just getting EMR up and running. So if we go back to kind of my CDK stack, we're, three stacks in here. So I've created a VPS, I've created RDS, and I've created EMR, and it's all been pretty dynamic, right? Even my EMR stack, which to this point is probably the most complicated one, that's about, 150, 200 lines of code, right? But it's a lot easier for me to manage this in Python and add tests for this type of stuff than it is to manage this elsewhere or do it manually. So this is pretty easy. I think that the nice thing is it's also pretty customizable too. So previously I mentioned with those with CDK, it's a lot easy. It's pretty easy to manage permissions. So I can say like, grant put to my job role, but I can also manage that manually if I want to. So one thing you saw down here, I have this log writer policy, and I'm not sure. I think I was experimenting with this before I just used the CDK thing. So if you wanted to, you could essentially write, raw IAM statements down here. I almost never want to write raw IAM statements. I would much rather let somebody else do that for me. And so that's where I ended up just using this grant put thing here that says, okay, cool, add that job role, figure out the IAM permissions yourself, and allow it to write to that bucket. So if I go back here, let's see if my notebook has spun up yet. It has, so I'm going to go ahead and open that up. And this notebook I created manually, but the rest of the stack was all created by CDK. And so if I hop into my notebook here, this is just pretty straightforward stuff. I use this notebook to go ahead and kind of populate that Hive metastore. Rapid7 has a pretty cool open data set on the registry of open data for AWS. And so I went and created a table for that, for those forward DNS queries, which is pretty cool. And so then I can just, pop that open in my notebook, go ahead and query that table and do some analysis of the DNS namespace if I want to. So that's that. So the next thing I want to do is show, okay, cool. You've got this RDS database, you've got this EMR cluster on EC2 instances. What if you just want to do it on, Kubernetes? Kubernetes is what all the cool kids are using today, right? At least that's what I hear on Twitter. And so what I want to do next is show how to provision an entire EKS stack with EMR on top of EKS. So let me close this here. Yeah. Let's close RDS. We'll leave EMR there as well because we're going to create that new virtual cluster. So we'll go back to my code. So with this code, I haven't really modularized it yet, but if I wanted to, I could say, hey, you know what? I don't really care about this RDS stack or this EMR stack, so maybe don't create those. Or maybe I just want to do EKS or what have you. But at some point, maybe I'll add some options in there, but I'm not going to do that quite yet. So cool. So what I want to do is I want to create a new EKS stack, and let's see what that looks like. So here's my EKS stack, and this one was kind of fun, right? And by fun, I mean I had to bang my head against the wall quite a few times, but mostly just figuring out how Kubernetes runs. Like I am by no means a Kubernetes expert. It's not something I use on my day-to-day, and so it's taken me quite a while to just understand how that works, how all the service permissions network and all this kind of stuff. So creating the EKS stack itself is pretty straightforward. I go ahead, I create a new cluster that's just named data team. In that cluster, I specify the Kubernetes version I want to use and the endpoint access and the VPC and subnets and all that kind of stuff. Now, when you spin up EKS, you also need to add some sort of node group capacity. So that could be managed node groups, that could be manually managed node groups, or that could be Fargate too. I'm adding a default node group here just to make things kind of easy for myself. And I'm going to add that with the instance type that's passed in. It defaults to M5XL. And then I can specify a min and max size. The other thing, you can pass in tags there as well. So just getting the cluster up and running, that's all it takes from the EKS perspective. You just add that EKS cluster, you add your node group capacity, and like you're pretty good there. But if you actually want to use it with other stuff, that's where it gets a little bit tricky, right? So I've got a few different things, and this code is a little bit incomplete right now, but I was experimenting with different things on getting that cluster up and running. So one thing, there is this add admin role to the cluster. And so this just means that when you create that cluster, you need to add an IAM role that can administer the cluster in the console. So that's all that's doing, is just passing in, I pass in a role name that goes ahead and adds that to the role that on the EKS cluster that allows it to manage it. So that's if you want to be able to manage that cluster from within the console. And then I have a couple other things that I'm going to add here. One is the Kubernetes Dashboard is sweet and allows you to look at the cluster. And then the cluster autoscaler is awesome because that will take care of scaling your cluster up and down depending on what resources you need. But getting those added to the cluster was definitely a little bit of a challenge. So let's see what that looks like on EKS really quickly. All right, so there's my EKS cluster. It's my data team cluster. It's pretty tiny. right now because I don't really have much running on it, but we'll see what happens when I do actually start to run some stuff on it. So if I flip back to here, there were two main things I wanted to add to that cluster. So one was the cluster autoscaler. This one was a little bit tough to figure out just because I'm not as familiar with Helm charts and installing things to the EK to Kubernetes and all that kind of stuff. So I did a bunch of experimenting, and I ended up kind of creating this little plugin where I can add a cluster autoscaler and enable autoscaling. And so let's see what that actually does. So in order to enable this autoscaling, there's a few actions that have to happen behind the scenes. You have to add tags to enable auto discovery. So the node group has to have certain tags. You have to create a new IAM role that can modify those auto scaling groups. You have to create a new Kubernetes service account. You have to create a new cluster autoscaler deployment, and then you have to create the corresponding rules in the EKS cluster. So that's a lot of stuff that has to happen. There is a cluster autoscaler Helm chart, but I don't think the new versions of the Helm chart are compatible with EKS. I tried to install that um, because CDK has a really nice add Helm chart construct, and I was hoping I could do that really easily, but it wasn't spinning up the cluster autoscaler, so I'm just kind of doing it manually. So here's all those different things in the cluster autoscaler in terms of tagging it, creating the service account, and adding the manifests. And again, this is this is all built in Python here, right? So I go ahead, I create that service account, I add in the necessary IAM policy to that service account, um, and then I also add some, that actual deployment to Kubernetes. So this is the same thing as doing like a, kube control apply with, a different manifest file or whatnot. So thanks, Rahul, for the tweet there. Appreciate that. Um, we'll see if some more folks join. So, all right. So I'm going to deploy this autoscaler, and this is mostly just a bunch of YAML that I've converted into JSON, right? So there's the commands for the cluster autoscaler. I've got a few things that I'm, kind of formatting into that command, but that is pretty much it. And it's not too bad. All these rules in the manifest I'm just pulling from the cluster autoscaler repository. I would have much preferred to use the Helm chart, but unfortunately I kind of had to do this manually. But now, if I do want to add that cluster autoscaler to an EKS cluster, I've got that simple plugin. I just pass in the cluster name and the node groups that I want to enable autoscaling for, and I'm good to go. So pretty sweet there. And let's check out what that looks like. So I've got my managed node group here. If I click on that node group, you can see those tags down here. So that was added by CDK, and that was added by CDK as well. And so now this thing is ready to go and ready to auto scale. So the other thing that I did was I added the Kubernetes Dashboard to EKS as well. So let's see what that looks like. This one was a little bit easier. So an enable dashboard. Thankfully, EKS on CDK has this add Helm chart. So I add a Helm chart for the right namespace. There's the chart. There's the repository. I'm overriding a couple things. So that full name override, I access the Kubernetes dashboard using kube control proxy. So I need to define the full name override. And then I got tired of my dashboard timing out in the middle of demos. So I set the token TTL to 0. So that's all getting passed over as part of the Helm chart. And there's a couple other things I'm doing there. I'm adding a manifest for the rules for that for the Kubernetes dashboard to be able to see all the stuff in the cluster, and that's pretty straightforward too. And so that was really it for enabling the dashboard. So I think I have this still running. So let me pull up my dashboard here, and I made the namespace a little bit different. I need to open the chat in the web browser. Eric, good question about speeding up Spark clusters using S3. Depends what you mean by speed up. If you want to speed up the writing or speed up the cluster spin up time. If you're talking about cluster spin up time, the EKS, EMR and EKS is actually pretty cool. I'll show how to run a job through EMR and EKS that reads data from S3. But yeah, that's a fun question that we'll get into. So here's my Kubernetes dashboard, and let's see. These are all the pods that I've got running in there. So you can see there's my cluster autoscaler, my core DNS stuff. There's my dashboard. So this was all provisioned using CDK, and then I just ran kube control proxy through that, so I could access the dashboard there. So getting the dashboard was pretty simple. I just did that add Helm chart there. And now I've got my EKS cluster, I've got it ready to auto scale, I've got a cool dashboard, and I want to add EMR on EKS on top of that. So let's go back to my base app here. And what I'm going to do is I'm going to create an EMR container stack. So again, I pass in the VPC and the EKS cluster, both dependencies for that EMR container stack. So we'll go here and let's see what happens with the EMR container stack. So in that EMR container stack, I pass in my VPC, my EKS cluster, and then what I do is I just kind of configure EKS for EMR. So when you're running EMR and EKS, let me actually pull up the docs for that. EMR EKS setup. So a couple things to mention about EMR and EKS. If you're not familiar with this, we just came out with this functionality back in December. We announced it at reInvent, and this allows you to run EMR jobs on EKS. So a lot of folks are moving to EKS. They're trying to consolidate their infrastructure. This allows you to kind of pick up your Spark jobs and run them on EKS really, really easily. The main thing about this is setting this up is, requires a bunch of steps, right? You have to have EKS set up. You have to enable cluster access for EMR to access EKS. You have to set up IAM roles for service accounts, create a job execution role. So there's a whole bunch of steps that you have to go through to actually get this up and running. And that is what this stack is doing here. So all the stuff you see over here, just in terms of like enabling cluster access, creating a namespace, we're going to do that in CDK. So the first thing we do is we create a namespace for EMR to use, and that is, I just have some helper functions down here. So that's just EKS cluster add manifest with my namespace. Then I create a cluster role. And so that goes and adds this big manifest down here that says, okay, here's a cluster role that can add all these different rules and whatnot. And then I add a dependency for that role that I created to the namespace. And then I bind the role to the user. So there's an EMR containers user that gets created inside my EMR namespace. And this binds that EMR containers user to an IAM role, right? So we do that. And then we've got a create job execution role down here. So one of the different things about EMR and EKS, every job runs with its own role, right? When you create an EMR and EC2 cluster, we saw before when I created that cluster, the whole cluster had a job role that was being used on that cluster. And so any job that ran on that cluster, they all just kind of share the same permissions. With EMR and EKS, you can actually specify a role on a per job basis. I'm just creating a default role here, and let's see what that role actually looks like. So yes, bad Damon, I'm adding some S3 full access and EC2 full access to that role. I know, scope that down, right? But this job execution role, it's pretty straightforward. So I'm creating that role. I grant the necessary access to that role, and then that's pretty much it. So that's really nice, right? The other thing that I'm doing down here, oh yeah, that's right. So one of the other things is you need to enable this IRSA on the EKS cluster. This step is a little bit tricky because you need to like get the cluster identity, and then you need to create a mapping, a trust entity inside your IAM role for the for that role on the cluster to be able to map from the Kubernetes user to the IAM role. So like it's really hard to actually get this right, and this is why I kind of love doing this with CDK, because once you figure this out, you can codify it, and then you can reproduce it a lot easier, right? And so let's look at what that ends up looking like. So that here's my EMR and EKS default role. This got created with CDK. And so when I go there, you can see there's my full access, and then there's the trust relationships that are built in. So this makes it a lot easier to actually kind of connect things between IAM and EKS. And Eric on the reading streaming S3, depending on, HDFS versus S3, it really depends on the data. Um, if you have a bunch of small files on HDFS, that is a little bit more performant than if you have those same small files on S3. So, really depends on the actual configuration and layout of the data. But yeah, feel free to ping me offline and we can discuss more about that. More than happy to. All right, so let's get back to this. So I've got my cluster, I've got my roles. I added a bunch of statements there. And let's see, let's go back up. Where was I? So there's my job execution role. And then finally, I can create my EMR virtual cluster. So the way that EMR and EKS works, you create a namespace on EKS, you map that namespace back to EMR, and then you create a virtual cluster for that namespace. And this is pretty straightforward. We just say, go ahead and use the EMR containers stack or construct on CDK, create a cluster, and then you pass in that cluster name right there. And so that goes ahead and creates a cluster for EMR on EKS. We do have a good CDK example just for EMR on EKS that we just put out recently. So this goes ahead and does something similar to what I'm doing. It creates an EKS cluster, two EMR virtual clusters that use either managed node groups or Fargate node groups, or sorry, Fargate profile. And then it can do some other stuff as well. So there's some managed airflow stuff in there and a EMR Studio stuff in there too. So that's a pretty awesome CDK stack as well. But let's see, let's hop back over here. All right, so super easy, right? I think that's, one of the challenges for sure, just in terms of like getting everything up and running, is figuring out, okay, how do all these things map together? How do the IAM roles map to, Kubernetes, service accounts, and all that stuff? So this took a little bit of time and effort to figure out, how to actually put this all together. But now that I have it, I can reproduce it. I can share this with the world and make it easy for everybody else as well. So if I switch back to my EMR console, what this looks like now is I've got a virtual cluster here. That's my data team connected to my data team EKS cluster, and it's connected to the EMR jobs namespace. So that's that. What I want to do next, let's see here. So I've got everything up and running now. I've got my VPC, I've got my EKS stack, I've got my EMR containers stack. Let's actually try to run a job. I'm going to have to go and find some code in order to run that job. So just give me 1 second. I'm going to hide my screen here. All right. So I've got my cluster ID, and I just need to find a job run. So I've got another demo that I just need to open up and get my code from. So let me do that really quickly. Source EMR EKS. All right. Yeah, why don't we use that? Got to set my S3 bucket. Cool. All right. I think this should work. We'll see. We'll try it. It's a live stream. What could possibly go wrong? All right, go ahead, clear that, and let's open up this. So this is going to be some shell code. All right, I think that's going to work. Make sure that code is actually there. All right, I'm going to take off my sh in a second here. There we go. All right, cool. So I think we're good to go. Welcome back. All right, So I've got that whole stack set up. Let's see what it takes to actually run a job on there, right? So now that I've got that stack set up, you can see I'm kind of already connected to the data team, my data team EKS cluster in my console here. One thing I forgot to mention, when you're running CDK, one of the nice things about it is you can output different information in terms of connecting to that cluster. So with CDK, when it creates an EKS cluster, it automatically outputs the command you need to execute in order to update your kube config to show that to be able to use that. So that is in the EKS stack outputs. So it outputs the config command. So if you wanted to connect to that EKS cluster using kube control, you could do that after running that command right there. So pretty cool. And there's also like a get token command for logging into the EKS cluster too. Before I hop into this, let's take a quick look at what this actually ends up looking like in your CloudFormation console. So that's what CDK is doing behind the scenes. It's creating all these different stacks for you. So the stack that I demoed earlier, there's my glue stack and my data containers stack. These are all the stacks that I created as part of that second part of the demo. So here's my EMR containers stack, and that is the Emr Virtual Cluster. You can see all the different resources there. So pretty cool to see all that. And then the EKS stack, the outputs that we just saw in the console, these are the same outputs that are going to be in the CloudFormation stack as well. So there's my update kube config command, my get token command, and everything else that I might need in order to be able to access that cluster. So let me flip back over here. I didn't know if this would take, how long it would take to go through this, but pretty cool. All right, so I've got a piece of code here. This is my Windy City code. And what that does, let's actually do a quick copy of that Windy City code, windycity.py, and I'll show you what that code does. Back in, I guess it was February, it was pretty windy here in Seattle, and I love weather data, and I love the fact that there is an open bucket of NOAA global hourly weather data. And so I put together a script because it was super windy one day, and I was like, hey, I wonder, what are the windiest, was this the windiest day of 2021? So I put together a quick script that goes and reads that data from S3, that's CSV data. It extracts some latitude and longitude stuff, and then pulls out the wind speed on a daily basis, and then and that's pretty much it. So what I want to do is I want to try and run that job. So I'm going to pull out a couple things here. That was some parameters I used in a previous demo. And so what I'm going to say, okay, cool. EMR container start job run. Let's run that on this virtual cluster. Let's name that job Windy City. This is the job role I'm going to use. And I actually don't want that configuration overrides. But what I am going to do, oops, code-n. Let's see, I've got, I do want to output this to CloudWatch. So let me do that really quickly. Awesome, cool. So I'm going to pull out this configuration overrides here. I was doing some work with the Spark dynamic allocation and testing that on EKS, so that's pretty cool. But what I do want to do, I just want to log this stuff out to CloudWatch. So we'll put that in EKS Spark. We'll name this Windy. All right, let's see if this runs. So this is the EMR containers start job run command. It's going to go ahead, submit this job to my virtual cluster that is going to run on that EKS cluster I configured. So we're going over here. Awesome. So that submitted the job. That's my job ID there. So if I go back to my my EMR virtual cluster, there's my EMR cluster there. And let's see, there's my dacort Windy City job. It's been submitted. And if I go over to my Kubernetes dashboard, what we should be able to see is, let's see here, there's my Spark driver spinning up now. So I'm going to change my namespace to EMR jobs. And you can see that that Windy City job is already spinning up. So there's the job submitter. That's EMR going and creating a job submitter that goes and runs this on the Kubernetes cluster for you. There's the Spark driver that's spinning up, and that spins up all the Spark executors, right? So super quick to spin this up on EMR and EKS, as long as you've got the node capacity. If I go to back to my EKS console really quickly, what we'll see here too is there's my one instance. And so you can see that one of my executors is running, but the other one is pending. And the reason it's pending is because I don't have enough cluster CPU. So in my EKS cluster, I've only got that one instance and I don't have enough capacity to run both executors. And so thankfully, I have the cluster autoscaler installed on there. And what'll happen in maybe another 30 seconds or so is that cluster autoscaler will say, hey, I see you want some more CPU, let me go ahead and add some more CPU for you. So that'll take, I think the cluster autoscaler runs every like 10 seconds or something, but that should spin up pretty quickly here. The other thing you can do with EMR and EKS is I can create this history server. So every job that you submit, you can view the logs of that job, whether it's completed or whether it's running. And so I can go in here and there's my Spark job. This is my Windy City job. And now you can see my job running right there. It's got about 10,000 tasks, so this might take a little while to run once those extra instances spin up. And the other thing, like I mentioned, there's one right there. So there's the cluster autoscaler kicking in and kind of spinning that stuff up. You can also run EMR and EKS on Fargate. And so that's really useful if you have a long running task or something like that, and you can just continually spin up more and more Fargate nodes. That's why I was experimenting with this dynamic allocation here, because it was really handy to say, okay, start off with 2 executors, or 5 executors, go all the way up to 100 if you need to, but spin back down. So this is really good for Spark jobs where you may need variable capacity throughout the lifetime of the job. The other thing we did here, we logged to CloudWatch. So let's go and take a look at CloudWatch really quickly. All right, so here is CloudWatch. And that's just pulling up. Here's my log groups. And where is my Spark log group? There we go. And so I should have a Windy. Yep, there's my Windy log group there. And so when EMR and EKS is running, you can log to CloudWatch or S3. And each driver and each executor has different log streams for standard out and standard error. So you can see I've just got my one executor there. Is that, that second one should be running shortly. And so that is the standard error, standard out of those different executors, as well as the driver, as well as the job submitter there. So this is where you can kind of dig in and start to debug your jobs. You can kind of see what the application status is in there. You can see all the debug information that's kind of coming out of there as well. And then once this job completes, it'll actually log something to standard error. But right now it is still chugging away on loading that data from the NOAA Global Hourly data bucket. So, if you've got 12,000 objects in a bucket, it's just by nature of physics, it's going to take a while to load all those. But what I can do next time is I can run this job with a lot more executors, right? If I have 100 executors, that means I can load the data in that bucket a lot quicker. I just have 2 executors, so you can see they're pretty overloaded, right? That one executor has done 5,000 tasks and barely, read any data. So that's one of the fun things there is with EKS, you can you'll be able to maybe I'll do a demo of like the dynamic allocation, because it's pretty sweet to see that spin up and down. But yeah, that's running that EMR and EKS job on Kubernetes. So that job is just going to sit there and run for a little bit. I forgot how long it took to run. But what I can also, I'm just going to submit another one. Why not? So let's override the application configuration and let's do some auto scaling. Let's see what happens there. So we're going to go here, override the application configuration as well, and we're going to say run this dynamically. Go ahead, add more capacity when you need. So this is going to be kind of interesting because the cluster autoscaler, it's not really intended to respond to real-time requests. It kind of scans every second, depending on the size of your cluster. It may take a while to scale up that capacity. So if you are running EMR and EKS, it's always good to chat with your EKS operator or whoever manages that cluster to say, here's the capacity that I'm going to need, here's the type of jobs that I'm going to need, and they can help kind of size that cluster respectively. So in terms of reading those CSV files, each of those executors are kind of, they're able to split up the reading of those different files. So you can see that if I go back to the executors tab, these are the executors that are going out and listing and reading in those files. So there is normally kind of like if there's a whole bunch of files on S3, the driver may have to go and list those files and then split them out and tell the executors to read them. And that's kind of what's happening here is um, it's listing those. I'm sorry for that refresh there. It's listing those leaf files and then telling the executors to go ahead and list those leaf files. So that is one slowdown that happens in Spark sometimes, is if there's a bunch of files and the driver has to list all those files and then split up the work between the nodes, that can slow things down a little bit. But if you a technique I've seen often is to, kind of, if you know the structure of the data, to go ahead and kind of distribute the listing of those files to the executors or something like that. But yeah, listing 12,954 paths and pulling that data in is definitely going to take a little bit. But now this job is starting to chug along and kind of calculate what the windiest days were. But let's see, let's go back here. Let's see if, oh, sweet. We already have some new capacity scaling up. So back on the EMR console, I submitted that second job. So that's going to be my dynamic allocation job. So let me go ahead and I'll launch the Spark history server for that job as well. And we can see all the executors for that job are spinning up. So I gave it an initial capacity of 5 executors. So those are all on container creating now. The cluster responded pretty quickly to that because the cluster autoscaler saw that we needed more capacity, and now it's spinning up some M5 XL nodes. Man, gonna need a break here soon, going on an hour. That's one of the other, kind of back to Eric's question in the chat in terms of breaking up the CSV file. That is one of the other bottlenecks that happens pretty often with Spark is, say you've got a giant gzip file that's sitting on S3, like a 10 gig gzip file or something like that, right? And that's not even giant in today's day and age. Gzip is not a splittable format, so the executors aren't able to split up that gzip file amongst themselves. So if you have 50 executors and you tell them to read a gzip file, only one executor is actually going to be able to read that gzip file. So having splittable files on S3 is something that's pretty important too. CSV, I forget how splittable that is. I'd have to go back and look at the Spark loader. But if you have, Parquet data is really great because those are designed to be distributed and splittable and stuff like that. There's different compression types that are splittable as well. So if you do need to compress that data, look into different splittable compression types too. All right, cool. So let's see how that job is doing. Oh, it's already spinning up more executors, which is pretty awesome. And my EKS cluster is probably growing exponentially here. So let's go back to that. Let's see what's happening. And yep, still spinning up. And so this one, yep, it's listing those leaf files. If I go to the executors tab again, let's see, both of those jobs are probably running right now. Yep. So on the executors tab, on this one, we can see I've got 6 executors now. The tasks are a lot more distributed amongst those executors. And what'll end up happening too is it's starting to spin up even more executors here. So that's the nice thing about dynamic allocation is it kind of pulls up and says, okay, I see you need more capacity. I'm going to go ahead and request more executors. And if you're running on EKS and you have a managed node group that can handle it, or you're running on Fargate, that EKS cluster can just start to scale up and up and up. You see, I just added another set of nodes here, so that's what's happening there. And again, this is all kind of built using that CDK template. So if I wanted to build another cluster or another virtual container, I can do that pretty easily. In terms of the best splittable compression format, I love your questions, Eric. I have to double check. I used to know that a couple of years ago. Snappy, I'm not a huge huge fan of. I've seen issues with snappy decompression in different systems, so I'm not a huge fan of snappy. But if you've got Parquet files, it's totally fine to use the combination of snappy and Parquet, or I want to say like bzip is pretty well supported in Parquet too, but I'm a little out of date on that stuff, so I'd have to go back and double check that. Um, but yeah, that's kind of the nice thing about Parquet too, is it'll compress inside the Parquet file itself, so you don't have to worry too much about that stuff. Go little EKS cluster, go. All right, cool. So yeah, like I mentioned earlier, I haven't really used Kubernetes a lot, so I love just kind of coming in here and seeing the cluster just like grow and auto scale and create all these containers itself. Um, so pretty awesome for me to be able to see that. I love it when computers do their thing and I don't really have to worry about it. So the other thing I want to do, let's see. Oh yeah, let's do one more thing here. While this is running, you can see there are more executors, more and more executors spinning up and starting to take away some capacity from those other ones. So we're going to let that churn for a little bit. One of the more popular frameworks for data orchestration, data ETL, is Airflow, right? So we do have managed Airflow at AWS, but I know a lot of folks run Airflow on their own clusters. So let's see what it would take to deploy Airflow onto my EKS cluster. And this is something I've been tinkering around with for the past couple days, because there's also an Airflow EKS operator. And so I want to see what it would take to kind of get Airflow up and running. So I'm going to go with the most recent version of Airflow, which is 2.0. And let me go back to my EKS chart here. All right, so you can see I had this commented out up here before to enable Airflow. So I'm going to go ahead and uncomment this, and let's look at what that's going to do. So if I go down to enable Airflow, I'm actually going to use the Airflow Helm chart for this. So I'm still getting used to the Kubernetes space. So when I tried to see how to install Airflow on EKS or on Kubernetes, there's a community provided Helm chart. There is an official Helm chart that's part of the Airflow repository, but it's not done yet. And so there's also Bitnami has some Airflow charts as well. So I wasn't sure which one to use, but I just settled on kind of the stable community version that is, finalized. So that's what I'm doing down here. I'm using add helm chart to go ahead and add my Airflow helm chart. So I'm pulling that from the Airflow helm repository there. There are actually I was just experimenting with this. I'm going to take that out for right now. So I was trying to use some instance roles to connect to allow Airflow to read from S3, but I decided not to do that, so I'm going to take that out right now. All right, cool. So there's a couple things. There's one tricky thing here. With Airflow, I'm deploying a non-production edition of Airflow here, right? So I'm just going to run Postgres on my EKS cluster. Um, in order to do that, I needed to create a storage volume on EKS that allows it to disconnect and reconnect. So there's this storage class here, and I had to change the volume binding mode to wait for first consumer in order to allow like a rolling restart of my Postgres node. So again, it's generally not recommended that you run Postgres on Kubernetes for your production Airflow, but I'm doing it here for this example. I could have just provisioned another Rds stack using CDK, but I just kind of wanted to do this in one shot and see how it went. So let's see, I'm going to add my Helm chart. I'm going to deploy that in the Airflow namespace. Here's the version of the chart I'm going to release, and then you can always provide different values in there. So I'm going to use the Kubernetes executor. There's my Fernet key that was generated just for this demo, so don't worry. I could also put that in a secret, and that would of course be the recommended thing to do there. I'm actually going to be pulling a custom version of Airflow from my own repository, so I'll pull that image in. And then because I'm running the Kubernetes executor, I'm disabling the workers and Flower and Redis stuff in there. And I'm going to pull a single DAG from my own personal repository. So that's that. Yeah, that's really it. Like I just said, add Helm chart, figured out all the config values, and I'm pretty much done. The other thing that I do is you can forward the port locally. And so what I'm going to do is I'm going to spit out the command I need to forward a port to my Airflow admin UI. So I build that command here, and then I just say, hey, output that in the CloudFormation stack. So I re-enabled that. Let's go ahead and do a CDK deploy and see how that goes. I always love doing live CDK deploys, don't you? Yes, I do. All right. So when this runs, what's really neat too is CDK is going to go through and it's going to look at all my stacks and it's going to see, is there anything new I need to add? Is there anything I need to remove? And then it's going to go ahead and create a CloudFormation change set for you automatically. So this is obviously really helpful, right? Because CDK kind of helps manage the different changes between your infrastructure, right? So all I'm doing here, I'm just adding a new Helm chart to EKS, but it's going to go ahead and deploy that as a CloudFormation change set. So let's see. Takes a little bit just to get that spin up. And there's no IAM changes in here, so it's just going to go ahead and deploy that straight from here. So let's go back over to CloudFormation just to kind of see what's going on. If I refresh my CloudFormation here, you can see my EKS stack is now being updated. And if I look at the events, you can see it's user initiated, and it's going to go through and run the commands necessary to install the Helm chart on that cluster. And this is one of the other really cool things too. So how is it installing a Helm chart on the EKS cluster, right? Is this magic? Is it, what is it? Well, it's not magic, but this is the cool thing about CDK is a lot of this stuff is built in, like the stuff you need is built in. So when it's going and running this add Helm chart, there's a bunch of Lambda functions that CDK has created out here. So CDK has some Lambda functions. These are custom resources that it can run during the stack deploy. And I'm pretty sure this one down here um, is one that actually will like run a kube control for you. So instead of you sitting here on your laptop running kube control apply or Helm install or what have you, here's this Lambda here that goes in and actually runs. Yep, there it is. Yep, sweet. So yeah, this is actually going to run like Helm install or Helm upgrade or Helm whatever to go ahead and get that installed on the cluster. So this is all like done for you. You don't really have to worry about it, which is really really nice. Because again, I would rather let um, the the professionals do this rather than me. I don't really consider myself a professional. Clearly, in my you know uh, brightly colored room here, right? So let's see what's happening with that deployment. Okay, so that's update in progress. Now it is going ahead and creating that Helm chart. So it's running that Lambda function. So if you did need to debug this, you could certainly like dive into these Lambda functions and go, okay, cool. Let's see. Let's monitor this. Let's go ahead and look at the logs for this Lambda function and kind of see what's going on. And this is what I had to do when I was trying to install the Helm chart for the cluster autoscaler, is I kind of hopped in here and I was like, what's going on with all this stuff? And this will show you the exact output of those Lambda functions. So you can see here, like it's creating a, what's it doing there? Oh yeah, creating that stuff. Oh yeah, creating a manifest there, adding a new context, right? So updating that context. This one is going ahead and let's see, creating that Helm chart. So it's installing that Helm chart. So you can go in here and you can actually see what's going on behind the scenes if you really need to. But if you don't really need to, then you deploy your stack and it's done. So I mentioned before, I configured my Airflow thing here to dump out the command I need to be able to access my Airflow UI. And this is documented, I think, in the Helm chart or what have you. But I'm never going to remember this command, like right? Like get pods, namespace, component, web, app, air. Like I'm never going to remember this. So it's really helpful to just kind of dump this out into my CloudFormation output because I can scroll up and I can be like, okay, cool. Here's my Airflow login command. Let me go ahead. I'll copy this and I'll do a no-hup and run that. And now I should have access to my Airflow UI. So let me pop that open. Localhost 8080. Takes a second to spin up. There we go. Now I've got Airflow on my Kubernetes cluster. So let me switch back. Oh, my EMR jobs are still running, but they're almost spun down. Um, so now I've got a new namespace in there. That's my Airflow namespace, right? And there's my Postgres database. Yeah. There's my scheduler. There's my web. And so now I can go on here and I can do all the stuff that I need to with Airflow. So now I've got Airflow deployed to my Kubernetes cluster. Awesome. And I've got all my DAGs in a Git repository, so it's going ahead and syncing those. Whoops. Oops, excuse me. And so, well, looks like the persistent volume persisted. So you can see my Kubernetes Hello World job here that kept running. And this is pulled in from my GitHub dacort Airflow example DAGs repo. So I've got just a simple DAG here that runs the Kubernetes pod operator, right? So that goes and runs either the Python 3.6 image or the Ubuntu image and tries to succeed or fail. So I'm going to go ahead, kick that off, and let's see if I can pick these up in, yeah, all right, cool. Go ahead, trigger that, and what we should see, yep, now we've got our Hello World passing task, our Hello World failing task, so those are spinning up in EKS as well. And now I can run all the Kubernetes stuff that I want to on on Airflow, and those are done already, right? And so let me refresh here. So again, like I'm I'm late to the game, I know, but I'm falling in love a little bit with Kubernetes. It just seems, I just want to run everything in Docker. If I could, just put everything in there that I need to run, whatever, I probably would. But yeah, so there's the task that I just ran. There's the passing one. There's the failing one. It's still trying to, retry the failing one, of course. The other thing, I haven't configured logs on here. So that would be one thing I would need to do. Airflow actually has remote logging, so you can log to S3. There was a bug in Airflow 2.0 in the major release where it wasn't logging to S3. It was actually hanging because of some threading issues. That is fixed in Airflow 2.01. So if you are running the most recent version of Airflow, then that would be something to watch out for. And there's another thing I noticed on Airflow and Kubernetes even with the 2.01 release where the scheduler seems to get hung up sometimes if you have a lot of DAGs, but I think that's going to be fixed in the 2.02 release of Airflow. So that is, I think that might be my cap for today. Trying to think if there's anything else that we want to look at. Here's my awesome Windy City. Oh yeah, let's look at the output of the Windy City job. So I think this one finished. So let me go back over here. Refresh that. Yep. So my first one is still running because it only had 2 executors. My second one already completed in 9 minutes. And let's look at the capacity of the EKS cluster. So that spun up. Look at all those nodes. If I run this again, I bet it will finish even quicker. You know, I'm just going to go ahead and run it again just for the fun of it. So, yep. Go gadget Spark job. Okay, so let's see how quickly that goes. But here is the one that I ran, and that scaled all the way up to 27 executors. So the next time I run this, I probably should have tweaked it so the executors started out at like 30 or something like that, because you can see it's not very well balanced right there. My first 5 executors did a bulk of the work until the rest of the cluster spun up. But with dynamic allocation, now that I have capacity on the EKS cluster, like look at all that capacity, the dynamic allocation is going to be much, much faster to respond. So let me refresh here and I'll pull up the Spark history server for that other job and we'll see just how quickly that goes too. So if I go back to my EMR jobs namespace, you can see there, it's already actually up to 11 executors. So like I said, the dynamic allocation can respond really quickly. I think it pulls every second or every 5 seconds or something like that. So it speeds up really, really quickly, right? And if I go back to my history server here, let's see. Yeah, because this job knows it needs a lot more capacity already, right? All right, pull that up, zoom in a little bit, take a drink of coffee. Welcome, new folks. I'm just about spinning down, but if anybody has any ideas on what they want to see about CDK or EMR, feel free to type it in the chat, and I can probably go for a few more minutes. And look, this thing has already, read 10,000, almost 10,000 of those tasks. So this is already spinning up to 19 executors. Man, see, I love technology sometimes when it works well. But the EKS cluster already had enough capacity for the dynamic allocator on Spark to go and request that additional capacity. So it's already up to 16 executors, and you can see it's much more balanced already between those first 10 executors. The rest are still catching up as the containers get created and all that stuff. But pretty awesome, to kind of have this running essentially, not necessarily serverless, but if I wanted to add a Fargate profile to this cluster, it could be entirely serverless if I wanted it to. So let's switch back to CloudWatch, and I want to see if what that Windy City thing actually did. So let me refresh my logs. And so, like I mentioned, all your executors, all your drivers, will have output in there. And so what I'm going to do, I'm going to scroll down to my driver standard out. So I think this is my first, yeah, it's my first job. So again, what this Windy City job did is it calculated the highest wind speed on each day in Seattle for 2021. So if I go ahead and load that, there's a lot of days in 2021, but we can see the max wind speed for every single day in 2021. I think that I gotta, do some data cleaning there. Got to do some data janitorial work. But I believe January 13th was that super windy day. So I believe that is, I think that's meters per second, not miles per hour. I forget exactly what the output of that is, but that was the day that was super windy. And you can see we had some other windy days earlier in January too. And we haven't had quite a windy day since then. We're only getting the top 50 rows, so I'd probably need to modify that to show everything. But yeah, that was a super windy day. It was really fun. Thankfully, nothing, well, maybe not fun for everybody, but thankfully nothing blew over, right? So all right, let's pop this up really quickly and just do a quick recap. So using CDK, I deployed an entire data stack. What's not shown here is my data ingest portion. I was able to deploy some Docker containers to ECS that ran on a scheduled basis, and those pulled data into S3, and then I created a Glue crawler that also populated the Glue data catalog from that data. That was really cool. And then I created this entire dual stack over here that had EMR and EC2 connecting to an RDS Hive metastore, and then EMR and EKS connecting to my EKS cluster, running both the cluster autoscaler and Apache Airflow. Again, I don't know exactly how many lines of code that it was to do this, but not many, right? I think the most amount of code in here are my manifests, that I pulled in from Kubernetes, right? So in order to put the stack together, it feels so um, feels nice to me to be able to kind of put a stack together in this way to say, okay, here's my VPC, here's my RDS. It ties into my EMR cluster or what have you, and it feels really easy to be able to manage and deploy these things. If I ever spin up a brand new account, I can just deploy these things really easily to a new account as well. Yeah, I think that's all I want to chat about today. Let me do one quick thing. I don't think I had Fargate in my. I didn't have Fargate. That's probably one thing I'll do later is I'll add some Fargate to this EKS stack as well. So let's pop back here. That job is running. That new job I spun up is probably already done. Let me go back to EMR. Refresh that. Yeah, it's already done. So yeah, that first job that only had 2 executors, still running. Second job that had to ask the cluster autoscaler for more capacity, 9 minutes. This last job on a warm cluster, already done in 5 minutes, right? So that's the cool thing about the cluster autoscaler too. If this capacity goes unused for about 10 minutes, it'll scale the cluster back down. So from a cost perspective, really awesome, right? And yeah, I think that's gonna be it for today. So I want to thank all the folks that joined. That was that was really fun. This code is available. I will continue to update it on my demo code repository. So anytime I do a demo, I try to update my code here. This is free for all to use. I've tagged it with the Creative Commons license there. And I've got some old demos from reInvent, but here's the CDK Big Data Stack. So you can see here, there's all the plugins and the stacks and all that kind of stuff. And I tried to describe, everything that I've done there. So that is my Big Data Stack on CDK. I've got some EMR demos in there too. I think my Windy City code is, yeah, there's my Windy City code that I used for this demo. So that's in there too. So go ahead, check that stuff out. If you have any questions about specifically EMR or EMR and EKS, feel free to reach out to me. I'm not a CDK expert, I'm just a user, but I really like being able to build my big data stack with CDK because this makes it a lot easier for me to build reproducible demos, right? So if you have any questions about EMR, let me know. If you have any questions, but just a bit in general about analytics at AWS, let me know. Feel free to ask me stuff about CDK. I can probably find the right person to pass it on to, but otherwise, I think I'll clock out for the morning, and thank you everybody for joining in. I really appreciate it, and I hope you have a wonderful Wednesday. Take care. Bye.